In this video, we're going to talk about rationalizing denominators. When we have a square root in the denominator of a fraction and the value underneath the square root is not a perfect square, it's important to rationalize the denominator. This video is going to discuss two common scenarios in which this happens. One is when there's only one term in the denominator and the term is irrational due to a factor of a square root with a non-perfect square underneath. Examples of number one would be something like 3 over root 2 or negative 6 over 5 root 7. Okay, now sometimes though there are two terms in the denominator and one or both of the terms has a factor that's a square root with a non-perfect square underneath. So an example of this could be 3 over 6 minus root 7, or 2 root 7 plus root 10 over root 2 minus root 7. Something like that. We've got two factors in the denominator, and two terms in the denominator, and neither one is or one or both is irrational. So let's talk about scenario one. There's only one term in the denominator and the term is irrational. When this happens, we'll multiply numerator and denominator of the fraction by the irrational factor of the denominator. So for instance, if we had the fraction 3 over root 5, we could simply multiply top and bottom by root 5. So multiply that. Now 3 times root 5 is 3 root 5. Root 5 times root 5 is root 25, but root 25 is 5. So we can say 3 root 5 is actually equal to 3 root 5. Sorry, we can say 3 over root 5 is equal to 3 root 5 over 5. And we've rationalized the denominator. Now, what if we had a fraction negative 8 over 2 root 6? Well, we don't actually have to multiply top and bottom by 2 root 6. We just have to multiply top and bottom by the irrational portion of the denominator. So the irrational portion was root 6. So we'll multiply top and bottom by root 6. Negative 8 times root 6 is negative 8 root 6. 2 root 6 times root 6, we keep the 2. Now, the root 6 times the root 6 becomes root 36, and root 36 is the same as 6. So we get negative 8 root 6 over 12. Now, what we can then do is factor 4 from the numerator. If you divide negative 8 root 6 by 4, you get negative 2 root 6. So the top is really 4 times negative 2 root 6. And the bottom is really 4 times 3. And we can then divide top and bottom by 4, and we get negative 2 root 6 over 3. Now, what if there are two terms in the denominator and one or both has a non-perfect square underneath a radical? Well, when this happens, we're going to multiply numerator and denominator by the conjugate of the denominator. Now, the conjugate of a binomial is the same as the original binomial, but with the sign in front of the second term changed. So, for example, the conjugate of 8 minus 2 root 3 is 8 plus 2 root 3. The conjugate of root 3 minus 2 is root 3 plus 2. So what if we wanted to rationalize the denominator of 6 over 3 minus root 7? Well, what we do is we take 6 over 3 minus root 7, and we determine the conjugate of the denominator, which is 3 plus root 7. So we multiply top and bottom by 3 plus root 7. Now again, the reason we're doing this more complicated one is because in this case we have two terms in the denominator. In the first two questions we only had one term, so it was a little less complicated. But since we have two terms, we figure out the conjugate of the bottom. Since the bottom was 3 minus root 7, the conjugate is 3 plus root 7. Whatever you multiply the bottom by, you must multiply the top. We then distribute. 6 times 3 and 6 times root 7 becomes 18 plus 6 root 7. Now 3 times 3 is 9. 3 times root 7 is plus 3 root 7. Negative root 7 times 3 is negative 3 root 7. And negative root 7 times positive root 7, negative times positive is negative. Root 7 times root 7 is root 49. Now, the square root of 49 is 7, so it's actually negative root 7. The reason why we use this method is these middle terms are going to cancel out. It's like a difference of squares. When those middle terms cancel out, it's a similar process. That plus 3 root 7 minus 3 root 7, they're gone. And downstairs, we're just left with 9 minus 7, which is 2. So we've got 18 plus 6 root 7 over 2. Well, we know that we can factor 2 from the numerator. 18 divided by 2 is 9, and 6 root 7 divided by 2 is 3. So the numerator is really 2 times 9 plus 3 root 7. The denominator is 2, so these factors of 2 cancel out, and we're left with 9 plus 3 root 7. So this value of 6 over 3 minus root 7 is better expressed as 9 plus 3 root 7. And another example would be the one you see here. Suppose we wanted to rationalize the denominator of this fraction. And actually, on the next slide, we've actually changed that to a minus. So we're asking you, we're going to rationalize the denominator of root 2 minus 6 root 5 over negative root 8 minus 10. Okay, so that's what it says here. There. Now, so let's get to work. The first thing we do is just rewrite the expression. That's exactly the expression written here. Now we have to determine the conjugate of the denominator. The conjugate of negative root 8 minus 10 is negative root 8 plus 10. So we multiply top and bottom by negative root 8 plus 10. And now we get to work with some expanding. Negative root 2 times negative root 8 is negative root 16. Root 2 times negative root 8 is negative root 16. Root 2 times positive 10 is positive 10 root 2. Then negative 6 root 5 times negative root 8 is positive 6 root 40. Just to refresh your memory, we're multiplying the negative 6 by the negative 1 and getting a positive 6 in front. And then we're multiplying the 5 times the 8 and getting a 40 underneath. Similarly, with this next one, negative 6 root 5 times 10. The negative 6 times the 10 is negative 60, and we keep the root 5. Okay, so our numerator is now negative root 16 plus 10 root 2 plus 6 root 40 minus 60 root 5. The denominator, we have negative root 8 times negative root 8. Well, negative root 8 times negative root 8, the negative times the negative becomes positive. The root 8 times root 8 becomes root 64, but the square root of 64 is 8. So that's actually just a positive 8. Now we have negative root 8 times 10. That becomes negative 10 root 8, because the negative root 8 had a negative 1 in front, and we multiply that by the 10 to get negative 10, and then the root 8 stays. Then we distribute negative 10 times negative root 8. Negative 10 times the negative 1 becomes positive 10, and we keep the root 8, so we have plus 10 root 8. And then the negative 10 will multiply by the positive 10, and we'll get negative 100. Okay, now, I know there's a lot of circles here, but I'm going to focus my attention here. Underneath that, negative 10 root 8 and positive 10 root 8 cancel each other out. And we're just left with 8 minus 100. So that's where this negative 92 comes from. Okay, now that negative root 16 that I'm circling right here, that's just negative 4. And we can't simplify root 2 or root 5, but that root 40 right there, the square root of 40 is the same as the square root of 4 times the square root of 10, which is the same as 2 root 10. So instead of saying plus 6 root 40, we can say plus 6 times 2 root 10. Okay? Now, 6 times 2 root 10, what we've circled here, hopefully you see that, that's just the same as 12 root 10, and so that's what we get. So we get to this stage, I'm looking at this fraction, we've got negative 4 plus 10 root 2 plus 12 root 10 minus 60 root 5. We know we don't like to have a negative denominator, so we'll factor out negative 1. But we also see we can factor a 2 from the numerator. So let's factor negative 2 from numerator and denominator. So factoring negative 2 from the numerator leaves us with positive 2 minus 5 root 2 minus 6 root 10 plus 30 root 5. Multiplying negative 2 from the denominator leaves us with 46. We can cancel out those negative 2's. And our final answer is 2 minus 5 root 2 minus 6 root 10 plus 30 root 5 all over 46. Now you might think, why is that more useful than that? And the reason is our denominator is a rational number.